Section 6.5, Perimeter Value and Interest Problems. This section we get no new material. We're just going to practice writing lots of different systems and then solve them using the methods learned in the previous sections. So the three main methods that we're going to be looking at are the graphing method, where we find the intersection point, the substitution method, where we solve for one of the variables and then substitute that expression in the other equation, and then the elimination method, where we do something to manipulate the coefficients on one of the variables so that when we add them together, one of the variables is eliminated. Okay, so this first section, we're going to look at perimeter problems. Kind of some of your typical geometry problems that pop up. So just as a reminder, so peri means around. And so perimeter is the distance around the boundary of some two-dimensional figure, where the area is the number of squares that it actually takes to cover it. Okay, so perimeter we're going around, and area is the number of squares it takes to cover it. Okay, so for a rectangle given below, it asks us to compute the perimeter and the area. So let's say this side here, we can say is 3 units long, whatever those units are. Typically we're measuring things in like inches or feet or something like that. And this side of our rectangle is 4 units long. And this side is also 3 units and 4 units. So if we want to compute the perimeter of this particular rectangle, we need the distance around. So as we walk around, if we walk down this outside part of the boundary, we would have traveled 4 units. And then if we travel this side, we travel another 3 units. And then we travel along this side, so we would have traveled another 4 units. And then finally this side is another 3 units, and then we're back to where we started from. So if we add these all together, 4 units plus 3 units plus 4 units plus 3 units, these are all like terms, and we get 14 units altogether. But now the area is the number of squares it takes to cover it, which if we count the squares in here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares. And we can get that by taking 3 times 4. So 3 units times 4 units. So 3 times 4 gives us the 12, but then units times units gives us units squared. Okay, so area is two-dimensional. We're going to get units like feet squared or inches squared. Perimeter will get labels like inches or feet. Okay, so in general, if we write our formulas, the perimeter, we can see that we have 2 lengths and 2 widths all added together. And to get the area, we took the length times the width. So let's look at one of the systems we set up at the start of this particular unit. So we had a poster for a film that needed to have a perimeter of 300 inches, and it also needed to have a height that was 4 times its width. Okay, so we had 2 different constraints on the problem, and we were asked to find the dimensions. Okay, so the dimensions are the height and width that meet these criteria. So we're going to define some variables. So we want to find the height and the width, neither of which have been given, so we're going to let x be the height and let y be the width. So if we write a set of equations to translate our sentences into equations, the word perimeter, we're going to substitute 2x plus 2y. Okay, for a rectangular poster, okay, our perimeter would be 2x's plus 2y's, and that has to be equal to 300. The other condition was that the height, which we called x, it had to be 4 times its width, where the width we let be y. So now we've got our system of equations. We want to know if there's an ordered pair that makes both of these equations true at the same time. So if we do a unit analysis on each equation. So unit analysis, we need to make sure that each term has the same units. So x is in inches, and 2 is a constant. So if we take 2 times something in inches, we're going to get this first term is all in inches. Our next term, 2y, again, y is in inches. 2 is just a constant without units, so 2 times something in inches, again, this term is in inches. And then on the other side of the equation, we had 300, which was also given to be in inches. Okay, so this passes unit analysis. Okay, all terms have the same units. And our other equation was x equals 4y, where x was in inches, y was in inches, and 4 was a constant, so 4 times something in inches will be in inches. So this also passes unit analysis since all these terms have the same units. All right, so if an equation passes unit analysis, it doesn't guarantee that we've written the equation correctly, but typically the most common mistakes students make will give you an equation that does not pass unit analysis. So now we're asked to solve the system. So our system has the variables x and y, so to solve the system means to find all ordered pairs. In this case, we only have 2 equations, so that make both equations true. Okay, so again, solve is one of those important verbs in mathematics that we need to know what we've been asked to do. All right, so in this case it says to solve using substitution, which this one is set up nicely for because it's already solved for one of the variables. Okay, nice. Since we have, without doing any work at all, we have x equals 4y. It's already solved for one of the variables. So we're going to plug that in to our other equation. So we have 2x plus 2y equals 300. And before I substitute for variables, I'm going to put parentheses around them. So in place of the x, we're going to put 4y. So removing parentheses, 2 groups of 4y, we have 8y, and 2 times y, we have 2y equals 300. 8y plus 2 more y's gives us 10y altogether. And to get y by itself, we're going to undo the multiplication with division, and we'll get y equals 30. Now again, if we look at what we wrote up here, to solve the system meant to find all the ordered pairs that make both equations true. So we're not quite done. So now x equals 4, and again I'm going to put parentheses before I substitute for the variable. So x equals 4 times 30, so x equals 120. So our ordered pair here is 120 inches and 30 inches, where x, if we go back up, x was the height and y was the width. So if we write our answer out here, the dimensions of the poster that meet these criteria are a height of 120 and a width of 30. Okay, so here 120 is 4 times 30, and the distance around the poster we would have 120 plus 120 plus 30 plus 30, which is 300. So it does meet both criteria.